Let us consider a system of linear equations in, we will not derive any method over there, okay? A system of linear equations in 3 variables first, like a1x, b1y, c1z equal to d1, a2x, b2y, c2z equal to d2, a3x, b3y, c3z equal to d3. This is system of linear equations in 3 variables x, y, z, and 3 equations are there. To solve this system, you have to define some determinants which are actually coefficient determinants. So let delta equal to a1, b1, c1, a2, b2, c2, a3, b3, c3. Delta 1 equal to, replace this column by d1, d2, d3. Then there will be b1, c1, b2, c2, b3, c3. Instead, delta 1, you take it for delta x, because this determinant is going to be responsible for finding the value of x. Solution means we have to get x, y, z. Now delta y, for delta y you replace this one by d1, d2, d3, a1, a2, a3, d1, d2, d3, and c1, c2, c3. And similarly, we will define delta z. Delta z means these things here will be replaced by d1, d2, d3. So a1, a2, a3, b1, b2, b3, d1, d2, d3. These are the values of 4 determinants. You know how to expand a determinant. For ordinary problems, no need to use the properties. But if you use properties, then some problems can be solved easily. After finding delta, delta x, delta y, delta z, we will be writing x by delta x, y by delta y, z by delta z equal to 1 by delta. So x going to be delta x by delta, y delta y by delta, z delta z by delta. Now for this system of linear equations, it is obvious that if delta is a non-zero quantity, then we can solve. So if we will be considering 3 different cases here. Case 1, if delta not equal to 0, then x, y, z, then x, y, z can be determined uniquely. Can be determined uniquely means unique solution exists if delta not equal to 0. This implies x, y, z attains unique solution only. Unique solution. You will get x one value, y one value, z one value. This will test with one actual problem, but before that, let me tell you other two cases. If delta equal to 0, then what will happen? If delta equal to 0, another thing, in the previous case when you get unique solution, then we can draw one conclusion from there, that is system of linear equations given system. Given system of linear equations are consistent. It means we can get values of x, y, z. Why? If you are not able to find the values of x, y, z, then it is said to be inconsistent. Okay? Theory derivations will not do here, but we must know the theory and find its quick application. If delta equal to 0, then there are two subcases over there. Number 1 or part A, if delta equal to 0 and delta x, delta y, delta z are all equal to 0. All must be equal to 0. I mean, all delta, delta x, delta y, delta z, all are equal to 0. In this case, the given system of equations, given system of linear equations are consistent. They depend on each other. They depend on each other and infinitely many solutions exist. Infinitely many solutions. You cannot state that values like 1, 2, 3, minus 1, minus 5, minus 7, not like that. You have to find solution in terms of variable, better to say, parameter, whatever. All three will depend on that parameter. I'll show you definitely, but let me complete this subcase. If delta equal to 0 and any one of delta x, delta y and delta z be not equal to 0, then the given system of equations are inconsistent. I mean, no solution will exist. Consistent means solution exists. So solution exists in the first case, solution exists second case, sub case B also. So here also system of linear equations are consistent. Let me take few examples to explain all these things. Once more, delta not equal to 0, then consistent, unique solution. Consistent and xyz attains unique solution. If all four determinants are equal to 0, then infinitely many solutions. System of equations are consistent, and if delta equal to 0, one of these things not equal to 0, then system of linear equations are inconsistent. We should keep these three things in our mind. To solve this, we will be writing all four determinants and solve them. The value of delta first, 6, 1, minus 3, 1, 3 minus 2, 2, 1, 4. This going to be 6 into 12 plus 2 minus 1, 4 plus 4 minus 3, 1 minus 6. 6 into 14 minus 8 minus 5. So 84 minus 8 plus 15. This is coming to be 91. Delta x, we will replace this by 5, 5, 8. Then 1, 3, 1 as it is, minus 2, 4. So this is not equal to 0. So your comment will be system of equations have unique solution. This comes under this category, no? Delta not equal to 0, unique solution. So this is going to be the case of unique solution. We are going to solve it now. So this will be 5 into 12 plus 2 minus 1 into, this is 20 plus 16 and 5 minus 24. So 5 into 14 minus 136 minus 19. 70 minus 36 plus 57. So this is 127 minus 36. 1, this is also 91. To find delta y, the middle one will be replaced by 558. This and this column will remain the same. 6, 1, 2, 5, 5, 8, minus 3, minus 2, 4, 6 into 20 plus 16, minus 5, 4 plus 4, minus 3, 8, minus 10. So 6 into 36, minus 40, plus 6. 216, 222, minus 40. This is 182. And delta z. Delta z is what? 612. Only this thing going to be changed by, replaced by 558. 131 and then 558. If you solve it, it will be 24 minus 5, then minus 1 into 8 minus 10, 5 into 1 minus 6, 6 into 19 plus 2 minus 25. So 114 minus 23. This is also 91. Now we can write the solution easily because we got all delta, delta x, delta y, delta z. Therefore, solution is what? X by delta x, that is 91, y by delta y 182, z by 91, 1 by 91. This implies that x1, y2 and z1. This is called unique solution. You got just one value of x, y, z. This stands for unique solution. Hope you have understood. How to prove that following system has no solution? Let us go back to the theory portion again. For no solution, what have I told? Inconsistent means no solution. Under what condition? Delta 0 and any one of these not equal to 0. Maybe two of them or three of them not equal to 0. Then the system of equations are inconsistent. So we are going to apply the condition over there to check whether solution exists or not. So you just write the value of delta 1, 4, minus 2, 3, 1, 5, 2, 3, 1. If you solve it, 1 minus 15 minus 4 into 3 minus 10 minus 2 into 9 minus 2 minus 14 28. So this thing 0. Let us find delta x. For that 132 will be replaced by 375. 413 minus 251. 3 into 1 minus 15 minus 4 into 7 minus 25 minus 2 into 3 into minus 14 minus 42, and this is minus 18, that is 72, and this is minus 32. So this is minus 74 plus 72. Not equal to 0. In this case, you won't be able to get the solution. And you don't proceed. You don't find delta y and delta z. Solution doesn't exist here because delta 0, but one of the delta x, delta y, z is not equal to 0. It ensures that this implies that no solution exists for the given system of test for a solution, whether unique or infinitely many or not. Let us check. So write the value of delta 1 minus 1 1, 2 1 minus 1, 1 into 2 minus 2 plus 1 into 4 minus 1 minus 4 plus 1. So 0, 3 minus 3, 0. Delta x is what? 3, 2, 1, minus 1, 1 minus 2, 1 minus 1, 2, 3 into 2 minus 2, 1 into 4 plus 1, plus 1 into minus 4 minus 1. This will be 0. Delta y, just replace this one by 3, 2, 1. 1, 2 minus 1, 3, 2, 1. 4 plus 1 minus 3 into 4 minus 1 plus 1 into 2 plus 2. So 5 minus 3 into 3 plus 4, that is 0. And for delta z, 1, 2 minus 1, minus 1, 1 minus 2, 3, 2, 1. This will be 1 into 1 plus 4 plus 1 into 2 plus 2, 3 into 5, 4 minus 9, that is 0. So this is the case where you are getting the values of all 4 determinants equal to 0. So what will be your conclusion now? As delta equal to 0, delta x, delta y, delta z all are equal to 0. So the given system of equations have, this implies given system of equations have infinitely many solutions. How to find those infinitely many solutions? You have concluded that as per theory, system of equations, 3 equations have infinitely many solutions. What are those? How to find it? You have to know the method of finding the infinitely many solution for this system of equations. As delta, delta x, delta y, delta z all are equal to 0. What we will do here, you replace any one of them as k. Let z is equal to k. Then x minus going to be 3 minus z and 2x plus y going to be 2 plus z, that is 2 plus k. Understood? Now
Yes,
solve
sir.
for x and then y. Adding 3x will be 5. X is coming 5 by 3. And subtracting, just do 2 minus 1. This one we got by adding 2 equations. K minus k get cancelled. And here they don't. If you subtract, 2y will be 2k minus 1. So y will be 2k minus 1 by 2. And k is any real number. So final solution going to be what? Final solution will be x 5 by 3, y 2k minus 1 by 2, and z equal to k. Okay, where k belongs to R. K is a real number, and this is the way to solve system of linear equations where all deltas are going to be equal to 0. This is system of linear homogeneous equations. Why homogeneous? Because right hand side equal to 0. I mean 0 matrix. So this time solution may be trivial, may be non-trivial. What is trivial solution? Trivial solution means all must be equal to 0. Non-trivial solution means at least one of the variable is non-zero. So trivial when you are getting 0, 0, 0, non-trivial when at least one of them non-zero. For this system of equations, for trivial solution, A1, B1, C1 A3, B3, C3 must be not equal to 0. Then solution is what? X, Y, Z all are equal to 0. Okay, without any hesitation you will put the values of all three variables 0 if coefficient determinant not equal to 0. For non-trivial solution, again one solution will be dependent on the other. For non-trivial solution, delta equal to 0, that is A1, B1, C1 A3, B3, C3 must be equal to 0. In this case, infinitely many solutions exist. Actually, the way I showed you how to get by using the value of k, that will apply here. Let us take these three equations, these two examples. Example 1, x minus 2y plus 3z 0, 2x plus y plus 7z 0, and x plus y minus z equal to 0. This is one, and another one is say 3x plus 2y plus 4z 0, then x plus y plus z equal to 0, then 2x plus y plus 3z equal to 0. Let me explain one by one how to write the solution here quickly. For the first one, we'll find just delta. Delta is going to be what? 1 minus 2, 3, 2, 1, 7, 1, 1, minus 1. 1 into minus 1 minus 7 plus 2 into minus 2 minus 7 plus 3 into 2 minus 1 minus 8 minus 18 plus 3. So you got minus 23, which is not equal to 0. Coefficient determinant not equal to 0. So the immediate solution will be trivial one. Without hesitation, you can say that x, y, z all are equal to 0. All three are equal to 0. Then it is done. Now, what will happen for next one? Let us find the coefficient determinant in this case. Coefficient determinant will decide whether solution will be trivial or non-trivial. Let us write delta over there. 3, 2, 4, 1, 1, 1, 2, 1, 3. This is 3 into minus 2 into plus 4 into 1 minus 2. 6 minus 2 minus 4 equal to 0. See, coefficient determinant 0. So in this case, infinitely many solutions exist and method will be similar. So you must write this implies infinitely many, that is non-trivial solution exist. Okay, but how to get those solutions which are infinite in number? So let me start this manner. Solution part I am showing you here by keeping this one in the same frame. So again, for the same method, let j is equal to k. And don't involve 3 equations, take just 2 of them. That will be enough. Put j is equal to k. 3 equations are there. We are putting j is equal to k in any 2 of them. So put j is equal to k in 2 and 3. Just do it there. X plus y plus k0 okay. So just subtract. So x equal to minus 2k and y is what? K. So what you are getting there? X minus 2k, yk and z is equal to k. Clear? Now k is belonging to real number set. So you will be getting infinitely many solutions over there. Whenever this situation arises, that coefficient determinant is coming to be 0 for a system of linear equations, then there are infinitely many solutions and you have to get it this way. X equal to cy plus bz, y equal to az plus cx and z is equal to bx plus ay. Where x, y, z are not all 0. So that this thing equal to 1. Obviously, sum is based on the concept you have just got. That is, system of linear homogeneous equations. Is it homogeneous? We have to check it first. See, in 3 equations there is no constant on the right side. Once we arrange in the form of system of linear equations, that is x minus cy minus bz 0, cx minus y plus az equal to 0, bx plus ay. Question they say they are not all 0. So it means this is the case of non-trivial solution. Non-trivial means non-zero, at least one of them non-zero. Non-trivial solution. So condition for it is that coefficient determinant must be equal to 0. So put 1 minus c minus b, c minus 1 a, b a minus 1 0, just expand it. 1 into 1 minus a square minus c minus ab minus b into ac plus b equal to 0. Just go on simplification. This will imply that 1 equal to, take every term on right side other than 1, a square plus b square plus c square minus abc minus abc. So 2abc. Done. In few steps only. For non-trivial solution, you have to get the value of lambda. Means the coefficient determinant equal to 0. If it is not equal to 0, unique solution, and that is trivial. x0, y0, z0. But here, for non-trivial solution, 2 minus 3 4 and 5 minus 2 minus 1 21 minus 8 lambda, this thing will be 0. So this implies 2 into minus 8 plus 3 into 5 lambda plus 21 plus 4 into plus 42 0. So minus 4 lambda 16 63. Oh my god, this is 2, no? So minus 8 equal to 0. This implies 11 lambda equal to, this is 63 minus 8, 55, 55 minus 16. So this one is plus 8, 11 lambda going to be 63 minus 55, therefore lambda equal to minus 5. One thing I'd like to say that this, whatever we have discussed so far, equally applicable for system of linear equations in two variables. What are those? That is a1x b1y equal to c1, a2x b2y equal to c2. Here only delta x and delta y will be there, delta also will be there. Delta is what? I just discuss it. because once you understand with 3, you can easily understand with 2. This is C1, C2, B1, B2, and delta y will be what? Delta y, for delta y you replace B1, B2 by C1, C2. Okay? So for non-trivial solution, solution exists if delta x, delta y, if delta not equal to 0, unique solution will be there. I am just writing it very fast so that you can revise also. For unique solution, what will happen? Delta not equal to 0. Okay, one value of x and y you will get.
So x
Now,
and
for consistent one, then for delta equal to 0, this is the case when delta not equal to 0. For delta equal to 0, 2 cases will arise. Case 1, delta x, delta y both are equal to 0. In this case, infinitely many solutions exist. Case 2, same way. If any one of delta x, delta y or both not equal to 0, then no solution, that is inconsistent. Then no solution exists. So for system of linear equations, it will be consistent here. In this case, consistent. What will happen here? In this case also consistent. In this case, it is inconsistent. If any one delta equal to 0, but any one or both delta x, delta y not equal to 0, in this case, system of equations are said to be inconsistent. Okay? So for this system of linear equations, you can see that there are 3 equations but 2 variables. One is extra. What to do with this one? 2 equations and 2 variables you can solve easily by determinant method, by cross multiplication, by any method. But if 3 equations are there, then determinant is a powerful method to check the consistency. If you find the coefficient determinant, if A1, B1, C1, A2, B2, C2, A3, B3, C3 equal to 0, then the given system of equations are consistent. Sometimes this is asked in exams, and here very common method is there to prove it. You solve these 2 equations by method of cross multiplication, by determinant, whatever. Then you put those 2 values of x and y here, you will be getting this condition. For this one, if we solve a1x, b1y, c1 0, a2x, b2y, C2 0, then solution is A1 B1 C1, A2 B2 C2, A1 B1 A2 B2. Remember it, this we take X, this one Y, determinant, the origin of determinant from here only, no? I am bringing them back. X by B1 C2 minus B2 C1, Y by minus C2 A1 is 1 by A1 B2 minus A2 B1. Okay? So the values of X and Y you got here. What is X? B1 C2 minus B2 C1 by A1 B2 minus A2 B1. Taking some time to derive it, because otherwise in this result you may be suspicious that whether it is true method or not. Y is C1 A2 minus C2 A1, that divided by. Hope you have understood the method. Now if the system of equations are consistent, then this X and Y must satisfy the third equation. Understood? For consistency, what will happen for consistency? The third equation has to be satisfied with this solution. For consistency, A3 into by A1 B2 minus A2 B1 plus B3 into C2 A1 by this plus C3 must be equal to 0. If you just simplify it, it is going to be A3 into B1 C2 minus B2 C1 plus B3 into C1 A2 minus C2 A1 C3 into A1 B2 minus A2 B1 equal to 0. You expand this determinant in terms of the third row. If you expand it in terms of the third row, the value of the determinant is this. So that is delta equal to 0. Means coefficient determinant equal to 0 for a solution of the given system. You could have done by this method, solve 2 and 3 and substitute 1. That also will work. But whatever you are doing here, the coefficient determinant 0 ensures that solution exists. Okay? And this is the time to try with sums asked in competitive exam based on all these concepts.